Alright guys, welcome to Math 0314, section 4.4, division of polynomials. Now, I'm going to preface this by saying that this is one of the harder sections that we'll discuss this semester, so be ready to work. This is going to be a little complicated. Okay, the first part really isn't too bad though. The question is what happens when we divide 3x to the fourth minus 6x cubed plus 9x divided by 3x. Now, first off, I want you to realize that when written like this is a quantity. And so when we divide, remember when we divide, it's the same thing as multiplying by the reciprocal. So we can say that this is in fact what we're doing here. And if that is the case, then if I distribute, as we did in the previous section, we are just left with 3x to the fourth over 3x minus 6x cubed over 3x plus 9x over 3x. And once we write it as such, then we can quickly see that in the first part, 3 divided by 3 is 1, x to the fourth divided by x is just going to be x cubed. Remember, when we divide, we subtract. This is x cubed. In the second part, 6 divided by 3 is 2, x cubed divided by x is x squared. And in the final part, the x's will divide out, and 9 divided by 3 is 3. And there's our answer. And that's it. Let's look at number 2. So go ahead now and pause the video and give it a shot. See if you can figure that one out on your own. Okay. And what I will say is that we don't have to do this step here initially. We can jump straight to here if you want to. So what I'm saying is that we can just rewrite this as 10c cubed d over negative 5c squared d squared. Because we know it's just the denominator, or what you're dividing by, the divisor, is going to be written at the bottom. Now what I'm going to do with this negative, I'm actually going to do a plus and put a negative 15 here. And then I'm going to divide by negative 5c squared d squared. And do the same for the last one. Okay, so we've written it out, now ready to attack it. So 10 divided by negative 5 is negative 2. Watch the signs. C cubed divided by c squared is c. D over d squared is going to leave me with d in the denominator. So again, remember we're subtracting the exponents. With the d, we have 1 minus 2, which is negative 1, which means d goes to the bottom. In the following one, negative divided by negative is a positive. 15 divided by 5 is 3. The c's are going to actually, and the d's are actually going to cancel out because they both match up entirely. And on the back side, we're going to be left with just negative 2/5, because you can't put 2 into 5. We're going to be having a c on the bottom because you have 2 on the top. I'm sorry, 2 on the bottom and only 1 on the top. Okay, and then the d, we're going to have d on top. And that's it. That's not too bad. Alright, so here's where it gets interesting, because when we're dividing like this, remember this is the same thing as saying this, right? These mean the same thing, first off, right? But if you rewrite this as such, there isn't much I can do from here. There's nothing I can do with, like we can on the previous one. The reason why is that we have, on the top we have a monomial, and on the bottom we have a binomial. So there's not really much we can do in that sense. So all we're left to do is what's called long division. So long division starts off as such, and though we're doing polynomial long division, this operates very much like regular division. So let's recall how we do division. Say I did 9 divided by 2. 9 divided by 2, what we do is we say how many times does 2 go into 9, right? And that's going to be 4 times. Then we multiply these, we get 8, subtract 1, and then the process repeats. Okay. Here we would conclude by saying 1 over 2, because 2 does not go into 1, So that's where we stop. So we say 4.5 or 4.5. Okay? So the same idea is going to persist here. So we're going to see how many times does x minus 2 go into 3x squared. But when we do this, as sort of a project of keeping our mind clear and not being overwhelmed with information, what we're really going to do is we're going to ask ourselves how many times, just take the first part, how many times does x go into 3x squared? Okay, I'm going to write that off to the side here, and it's going to go in 3x times. So I'm going to write 3x. I always like to map it, so notice that this is x and this is x. So I map them. You don't have to, but I think it keeps it clear. Let me erase this. And then we're going to distribute. So we're going to take 3x, we're going to multiply by x, and we're going to get 3x squared. And we're going to take 3x, and we're going to multiply by negative 2, we're going to get negative 6x. And here comes the very important part. Next, we're going to subtract, and when we subtract, we have to change the signs of both of these. I actually recommend doing this with multiple colors to keep yourself clear. What should always happen when we do this is that the first pair will subtract out. And this we're going to be left with negative 8x plus negative 10. All right. Next up, we're going to repeat the process. We're going to say, how many times does x go into negative 8x? So we're saying negative 8x divided by x, which is negative 8. So we go over here, we put a negative 8. And then we repeat. So we're going to distribute negative 8 to both of these. We're going to get negative, let me erase that underline right here. So this is 8x. So we're going to subtract negative 8x. We're distributing negative 8 times x is negative 8x. Negative 8 times negative 2 is positive 16. And then, once more, we're going to subtract, which means subtraction just is a fancy way of saying change the signs. So again, these should subtract out, and we're going to be left with negative 26. Now, just like earlier, we said that because 2 does not go into 1, we just leave it as 1/2. The same idea is going to persist here. X does not go into negative 26, so we conclude with plus negative 26 over x minus 2. All right. And something else here that's really interesting is, and I know there's a lot of going on here, but these two right here, these two right here multiply, and they should give us this. So x minus 2 is called the divisor. 3x squared minus 14x minus 10. I know there's stuff all over the place. This is called the dividend. And the solution is called the quotient. And I'm bringing this up because if I take the divisor and the quotient and I multiply them together, so if I took x minus 2 and I multiplied it by 3x minus 8 plus negative 26 over x minus 2, let's make sure I wrote that right. Yeah. If I did this problem correctly, then what should occur is that I should end up getting the dividend. So it should give me 3x squared minus 14x minus 10. And as an exercise, let's see if that's the case. So I'm going to take x minus 2, I'm going to multiply x minus 2 into all of these. So notice we're doing distribution, but I'm using one of the other methods, not foiling. And there's a reason behind this, and we'll see it shortly. So I'm putting x minus 2 in the back. So I'm essentially rewriting these and putting x minus 2 in the back. Oops. And so I hope it becomes apparent now why I did this. And the reason why is, on the back side, the x minus 2's will divide out. And that's the reason why. So now we're going to take 3x times x and distribute it. Take 3x, distribute it into x and into negative 2. So this is going to be 3x squared minus 6x. We're going to do the same thing here. Watch your signs. Negative 8x plus 16. and then we have the plus negative 26. So if we clean this up, we get 3x squared minus 14x. These will give me negative 10, and that is exactly what we originally had as our dividend. So it's a lot. It's going to take some practice to get used to. I encourage you to rewatch this video, but let's keep going. So here's another example. So again, we're going to rewrite this as 2x minus 4 into negative 2x cubed minus 10x squared plus 56. Now, I want you to note something here, and this is totally a legit move, right? We could solve this and we could get the answer, but there is a shortcut to all of this. And that's, if we recall, I can rewrite it as such, right? And what I can do here is, I think you guys see this, is that 2x minus 4, you can factor out a 2 and rewrite this as 2 times the quantity x minus 2. All right? If you don't believe me, distribute it back, and you'll see you'll get 2x minus 4. And then we can see on the top, all of the numbers on the top, all of the coefficients on the top are divisible by 2. So why don't we take out, actually I'm going to take out a negative 2. And so what we see here is the 2's will divide out, and we're left with such. Now, I made a silly mistake here. Not really a mistake, but the negative doesn't matter. You're still going to have the negative inside. So this just will be negative x cubed minus 5x squared plus 28 over x minus 2. And so that makes the number smaller. So now when I divide, I'm at least working with smaller numbers. Okay, so let's attack this. So again, what we do is we take the first 2 and we're going to divide those. I'm putting blinders on. I don't care about the negative 2 right now. Okay, and then we're going to distribute. I don't know why I wrote negative 2x squared. It should just be negative x squared. So we distribute. All right. We change the signs. Okay. And then we repeat the process. So we're going to ask ourselves, how many times does x go into negative x squared? And this goes in negative 7 times, so we'll go negative 7. And this will give me, we'll distribute once more. And this will give me negative 7x plus 14. Now, something that we see that's very interesting here is that, let's go with yellow. We see that these two do not match. And this is a very important note. They do not match, and the reason they do not match is not because of the 7's, but because of this is x squared and this is x. All right, and this is a problem that occurs in this situation. So what I could do is I could shift this over and have the negative 7x plus 14 off to the side. So I could rewrite this as negative 7x plus 14 off to the side and continue on the process. Okay, what we typically do is in the beginning we include another term here. We put in a 0x term, and what that does is it it's essentially a placeholder, right? So what we really want to always have happen, and this is true on either the divisor or the dividend, we want these to have exponents that always decrease. And if that is not occurring, then you just insert a 0x, or a 0x squared, or a 0x to the fourth, or whatever it is, okay? So I'm actually going to rewrite this problem, and we're going to go about and see, I don't have enough space here. Let's rewrite the question, and then let's attack it. So let me just go ahead and do this here. Well, I think it might be faster with the eraser. So let me erase all of this. I know. It also gives you an opportunity to practice again with this, so it's kind of a good thing. Hopefully my erasing is entertaining. And like I said, I'm going to include a 0x term, and I believe that was plus 28. Let's double check. Yeah. Okay, so now we're going to re-attack this problem. This time when I attack it, I'm going to go a little faster. So we're going to see how many times does x go into negative x cubed. This is going to be negative x squared, so we're going to have negative x squared. Distributing, we get negative x cubed plus 2x squared. Then I'm going to subtract, which means I'm going to change the sign, so I'm going to get negative 7x squared. This is going to subtract out. I'm going to bring down the rest of it. And then we're going to repeat the process. So negative 7x squared divided by x is going to give me negative 7x. This is going to give me negative 7x squared plus 14x. Note again, you must change the signs. So now we have negative 14x. Again, this cancels out. Plus 28. Keep it going. We're going to put in, I think I can go with green. Put in x into x cubed, negative x cubed, and that's going to give me negative x squared. I'm sorry, I wrote that wrong. We're putting in, let me fix that. So this is what happens when you go too fast. We're putting in x into negative 14x. Apologize. So let me be clear here. This is negative 14x, this is x. We're dividing these two. So this gives me negative 14. And again we're going to distribute this into here. This is going to be negative 14x. And we're distributing negative 14 times negative 2, which is positive 28. This one actually worked out to be nice. Finishing it off, change the signs, and this becomes 0. So this is our final answer. So, important here, if you have a x squared term and then you jump immediately to the conclusion, you need to insert the 0x as a placeholder. And I really, really, really do encourage you to do that. Okay, so let's hop on here and let's try this one. Note initially that the issue here is that this is not written in descending order. So we want to write it in descending order. So we should initially start off rewriting this as 9x to the fourth plus 15x cubed. I'm actually going to insert a 0x squared term. And the bottom, I'm going to actually have to do the same. I'm going to have 3x squared plus 0x, right? We want them in descending order, so we have x squared, x, and then the constant, minus 4. Now from here, you should be able to solve this on your own. I know it's kind of it's a lot longer than the previous ones, but it's essentially the same process. So if you haven't done so already, pause the video, go ahead, try to solve it on your own. I'm going to assume that you've done that, and now let's take it on together. So we're going to be left with 9x to the fourth plus 15x cubed plus 0x squared minus minus 4x minus 5 here. And on this side, we're going to have 3x squared plus 0x minus 4. And so we're saying how many times this 9x to the 4th is divisible by 3x squared. That's going to be 3x squared times, so I like to put it here, so we have 3x squared. We're going to distribute into all of these. And this will give me 9x to the 4th. These two should always match up. Now here's interesting, 3x squared times 0x is going to give me plus 0x cubed, right? This is going to give me 0, but I'll write it 0x cubed. And we'll distribute once more, and we'll get negative 12x squared. So everything should be lining up. We're going to change our signs. And then we're going to combine. So clearly this goes away. This is going to leave me with 15x cubed plus 12x squared minus 4x minus 5. We're just bringing the last two down. Okay, so let's keep going. So now we're going to put 3x squared and 15x cubed together. So we have 15x cubed divided by 3x squared, and this is going to give me 5x. So this becomes plus 5x. Once more, we're going to distribute into everything, and this will give me 15x cubed plus 0x squared minus 20x. Once more, we're going to change the signs. So this is negative, this is negative, this is positive. These once more will cancel out. We're going to be left with 12x squared plus 16x minus 5. And believe it or not, we're going to repeat the process once more. So we have 12x squared. We're going to put 3x squared into that, and that's going to give me 4. 4. Right? So we're using these two, putting them into each other. And so once we get there, we're going to have, I said what, 4? So this will be plus 4. We're going to distribute the 4 into everything. And this will give me 12x squared plus 0x, or 4, so it's negative 16. We are at the end of this problem. Yay! And so to finish it off, we're going to subtract, which means we're going to change the signs. And this is going to leave me with 16x plus 11. Now notice that x squared cannot go into x. So the final answer is going to be, we're just going to say plus 16x plus 11 over this. And now typically they usually just rewrite it without the 0x term in there. So it'll look like that. So time consuming, yes, but it's not too bad. All right, so there we go. There's number 5. Let's look at number 6. Now, there is another way to do this, and that is using something called synthetic division. Now, I want us to compare synthetic to long division. So I'm going to try to squeeze in here long division. This is x minus 2. And over here I'm going to do synthetic. Now synthetic, the way synthetic works is you're going to take this value here, but the opposite of it. So we're going to take 2. And then you write the leading the coefficients and the constants. So this is 3, negative 14, minus 10. Okay, and what we do is you take the first one and you just bring it straight down. Okay, then you're going to multiply these two together, and the result you're going to write here. So you're going to do 2 times 3, which is 6. You know, put that there, and then we're going to subtract. So this gives me negative 8. And then we'll repeat the process. So we're going to multiply 2 by negative 8, and we're going to get negative 16. And then we're going to put them together, and we get negative 26. What happens here is that if it starts off with x squared, then this will become the x term, this will be the constant, and this will be the remainder. So the answer here is going to be 3x minus 8 plus negative 26 over x minus 2. Remember, when we write the remainder, it's going to be over what we're dividing by, which is x minus 2. Now, once you get comfortable with this, you actually most students gravitate towards synthetic. Okay, so again, this is called synthetic division. Okay, but let's see why it works. So if we do this the traditional way, we're going to put x into 3x squared, and I'm going to get 3x, distribute that in, we're going to get 3x squared minus 6x. I want you to notice what we're going to do here. I'm going to subtract, which means I'm going to change the sign. And so this will give me negative 8x minus 10. And what I want you to notice here is that this value and this value are the same. Now, the reason why you change the sign here is because of the subtraction, right? So that we have this effect that we're just adding negative 14 to 6 to get to the negative 8, right? But we also drop one term, right? Because this is actually, the negative 8 is actually this value here, not this one. Because the next move is to divide this, to say how many times does x go into negative 8x, right? And this is something else, this also leads up to something else that's very important to understand, which is you can only do synthetic when it's linear, and this has to be a 1, okay? So there are ways around it. So like if, for example, if I'm asking you to divide by 2/3 x, well, let me not make it so complicated. Let's say I'm dividing through by 2x minus 5, then 2x minus 5 is the same thing as x minus 5 over 2. So you can divide through by 2, and now we have something we can work with. And we'll talk more about that later. But what's important is, what I want you to see here is that synthetic is long division, just cutting out the excess part, and that but it only works. You can only do synthetic if this is linear. I guess I meant to circle it, is linear. Okay, so let's finish this up. So we're going to go negative 8 times x gives me negative 8x. Negative 8 times negative 2 is going to give me positive 16, but once again, we must change our signs. And this is supposed to say 10, so this is going to give me negative 26. And that's the same thing here. So, there you have it. Let's quickly, I'm almost out of time. I think this is the last one. Oh, got 2 more. Let's quickly go through this via synthetic. Now, keep in mind, you got to put these in order. So this is going to become x to the 4th plus 4x cubed plus 5x minus 6. And this is going to be divided by x plus 3. Notice we have an issue here because this is 4, 3. There is no 2, so I have to insert a 0x squared term here, 1. And now we're ready to rock and roll. So remember what I said. You put the opposite of this. Write down the leading coefficients. Don't forget the 0. If you don't put the 0, you're going to miss the question. So bring the 1 down. You're going to multiply negative 3 by 1. It's going to give me negative 3. And then you repeat the process. Everything drops by 1, so this is x to the 4th. This is going to become x cubed plus x squared minus 3x plus 14 minus 48 over x plus 3. And there you have it. So real fast, I only got less than a minute to explain what's going on here. When you do this one, you're going to have to put in plus 0p minus 81 for this value here. So go ahead, pause. Let me put it this way. In the next video, we'll finish up this problem here. All right, so see you guys in the next video.